Hey, what's up everyone? Jason Turley here, back with another video. Today I wanted to address a question that I've been seeing asked quite frequently, especially in some subreddits and discords that I'm in, and that is how to get started with binary exploitation. So I threw together a blog post, a resource, an article on how I would recommend getting started, how to go about learning the knowledge and actually getting hands-on experience via capture the flag and war game platforms. So on this little right hand side, I do have a small agenda for us. We're just going to review this article that I wrote, and I will link to it in the description, and as well as I'll showcase two platforms that I really like, those being PWN College and Ret2 Systems. And if you stick around to the very end, I do have an update on some of the merchandise and whatnot we do have going on the channel. So hopefully this is large enough and everyone can read it. Let me resize this. Sweet. So how to get started, the TLDR, my notes are just, hey, the prerequisites, learn C or C++, learn assembly, and any assembly language is fine. I'll give some specific recommendations later, and as well, learn how to use the Linux command line or the Linux terminal. Also, create a free account on PWN College. It's 100% free, and it's from some pretty reputable people in the industry, so there's no reason not to create one, and complete some of their lectures and the modules that they have there. Additionally, supplement with different capture the flag challenges. So if that's all you wanted, right, you can click off the video now. However, we will break into these in a little bit more detail. So some prerequisite knowledge that I think you need to learn binary exploitation is C programming. So you need to understand how C works, because it is a very low-level programming language, and it will teach you different things like memory management, input and output, the layout, memory address space of a process, different things like that. You don't have a lot of the niceties in a higher-level programming language like JavaScript or Python, and you will have to implement a lot of things on your own. So learning how C works, it will teach you a bit about just computers and processes and operating systems in general. So that's just great knowledge to have, because when you get into binary exploitation, you might be tasked to exploit different kinds of hardware or software. So not just traditional computers, but maybe also IoT devices, smart cameras, medical devices, computer servers, applications, different things like that. So just having a more well-rounded understanding, and a lot of those things are going to be written in something like C or C++. You don't need to be a developer. You don't need to be a programmer. You don't need like out of this world knowledge. However, a good understanding of the C programming language is essential. And one resource I do recommend is, I think it's just called C by Example. Let's see if I can find that. Yeah, this first result here, C by Example. So when I say C, you could learn C or C++. C was the first one, and then C++ is kind of like its successor in a way. It has a lot more features and whatnot, but it's a lot bigger of a programming language, and it's something completely different, essentially. I wouldn't say C and C++ are the same, but they are very closely related. Pick your poison on which one you want to get started with. I think it's easier to learn C just because it's a smaller language, whereas C++ just has so many more additional features. It might be a little bit overwhelming for a beginner. So if you're brand new, I'd recommend going to this website, C by Example, and going through some of these exercises, right? So you can go to the Hello World, and it will show you how to write this in both C and C++. So pick your poison there. It'll give a little description on what you're supposed to do or what these things are. And for like extra credit, if this is like too simple, you can implement this in C, and then you can use a tool like a debugger, which we'll get into later. You can use a debugger and look at the assembly, and that way you're kind of learning both at the same time. And that's a good transition to this next section. You should learn some type of assembly language. So if C is a low-level language, assembly is even lower than that. It's pretty much the closest thing you can get to just straight up ones and zeros, Assembly, you're working with opcodes and instructions, and it's very primitive. It's like move this value into this register, store this thing at that location. There's really no abstractions whatsoever. You could probably get started with any assembly language, but here I recommend learning Intel x86, which is a 32-bit architecture, or it's a language for 32-bit architecture. You could learn x64 as well. However, x86, it is a little bit more simpler once you get into learning about calling conventions and different things like that. And it doesn't have as many registers as x64 does. So I think if you learn x86 first, you kind of understand that reasonably well, and then you can build on top of that by learning x64. Because a lot of modern applications, for example, the Windows operating system, is 64-bit. But the knowledge, it does build on each other. It does stack. There's no such thing as like useless or wasted knowledge in this field. So learning both is ideal. If you're just getting started, you just want to test the waters, I'd recommend learning some C. And if you like that and it's fun, open it up in a disassembler or a debugger and look at the assembly in x86. Yeah, and right here I have a little note saying you don't need to be an expert in assembly either. You don't need to be an expert in any programming language to get started. You're not going to be a coding wizard. You don't have to do binary exploitation. But you do need a solid grasp on some of these topics, and the ones I have listed here are the purpose and the use of the different CPU registers, function calling conventions. So without getting too into the details, when you're exploiting something on a Linux machine, like it's an ELF binary, that's going to be different than executing or exploiting something on a Windows system, portable executable. They just have different calling conventions and the way functions are called and who returns the data and who saves this value in what registers. It is a little bit different. And you have the different memory segments of a process. So the stack and the heap, what is that? The data segment, the code segment, and etc. Right? So as long as you have a good understanding of these concepts, you can always build and learn as you go. So here is a very rough study plan that I have linked. So I'd recommend starting with C by example. They were already looked at. So complete the different lessons. And here, personally, I'd recommend using something called a text editor and not an IDE. An IDE is short for Integrated Development Environment. Something like Visual Studio or PyCharm, something like that. They're huge applications. You can write code in them. You can run the code in them. It's like an all-in-one solution. And they're great, and they come with autocomplete features. They have like boilerplate templates for different things you want to create. And if you're like a full-time programmer or developer, sure, 100% use an IDE. However, if you're just getting started, I think working the hard way through like a text editor, at least initially, without any fancy tricks or tools or autocomplete, I think that will help you learn the syntax. Just personal preference. Let me know what you guys think in the comments below. Do you recommend a beginner use something like a IDE that has all these niceties, or just go bare bones with a text editor like Visual Studio Code or Vim, which I personally prefer, because this will force you to write all your code yourself, and then I recommend compiling it with a compiler like GCC. But Clang also works, doesn't really matter. So although this might feel tedious at first, learning to compile and debug your code is a very critical skill. Next, learn assembly and how to debug. We kind of already went over this, but as you work through the lessons from that C by example website, try loading those compiled binaries into a debugger. A debugger is just a way to step through your code, see what it's doing step by step. Because when you compile a binary and you run it, it's just going to go through everything. So if you can set breakpoints and look at the assembly and look at the different functions, it will help kind of paint that picture of what actually is going on underneath the hood. For me personally, I really didn't understand pointers or C strings very well until I started learning assembly, and then you learn all a pointer is a variable that stores the address of something else, right? So if you have an integer pointer, it points to the address where that integer is stored. What else do I have? I'll also say if you're using a debugger in the very beginning, skip these nice tools like GDB Data or Debug. These are plugins for GDB. GDB is the GNU debugger, and it's fine on its own. It can do a lot, and you can customize it. If you watch any of my previous videos, especially the ones from the ROTPorium, the return-oriented programming series of challenges I've done, I use a plugin called GDB Data. If we open that up, we see it is just an exploitation framework. It's assistance, and it makes, here we go. We have a nice pretty screenshot here. It makes debugging and disassembling code a lot easier. It will automatically print out the contents of the stack, the contents of different CPU registers. You can create different patterns, so you can like fuzz the binary easier if there's a buffer overflow. You can see here that they created a huge sequence of characters right here, and it's awesome. But if you're just getting started, it might be overwhelming. So if you've noticed a pattern here, I always kind of recommend starting with like the bare basics. Understand how the fundamental tool works, like a text editor, or how GDB with no plugins or extensions. Learn how that works, and then you can add on and like automate stuff and use these plugins, use IDE, use GDB frameworks. What else do I have? Learn basic Linux terminal usage. I personally just like Linux. Windows is fine as well. However, the default Windows CMD or the default Windows PowerShell, it's not as like feature rich as something like the Linux terminal is that has like a bash shell. It's just, in my opinion, it's just a lot simpler. It just makes sense logically. All the output is text, so it's very easy to pipe it into like grep or cat or set or awk. And once you learn a little bit, it does kind of feel like a superpower or like a game, and it is pretty fun. So I recommend this war game called Bandit from overthewire.com. I don't remember if I have any videos on this. I think I do. They might be pretty old, but I do think I have a few videos walking through solving some of these challenges. I know I have a blog post on it. I don't know if I made a video. And if you do get stuck at any point with anything at all, feel free to read some type of walkthrough or write-up. There's no shame. We all start somewhere. Moving on to some of the more fun bits, capture the flag challenges, the bread and butter of this YouTube channel. So capture the flags are personally my favorite way to learn any kind of cybersecurity topic, especially the low-level technical ones. So look for some beginner-friendly ones like Pico CTF, Over the Wire, Try Hack Me. And then again, if you get stuck, don't feel afraid or ashamed to look at some walkthroughs or write-ups. And then beyond CTFs, you do have things like Exploitation, which is, so CTFs are kind of one-off challenges. You solve them, you get some points, and then you move on with your life. War games, they kind of start as a series. So if we come back here to Over the Wire, or even if we open up this Narnia one, we see here on the left-hand side, there's different levels. They all have this like set difficulty, with this being 2 out of 10. There's 10 levels, and it's for the Linux platform, all 32-bit binaries. So again, this would be a perfect way to start. But all the levels kind of build on each other, and they do get a tiny bit more difficult on each level. So perhaps level 0 is simple as cake, and then the next one is easy as pie, and then you keep going up, and they get a little bit more difficult until you get to the end. So it kind of tests your knowledge and reinforces that throughout every level. I've personally solved these, and I do recommend it. I like the folks behind Over the Wire. It's a great resource. It's been up for several years. So that's just like a testament to the quality of product that they put out. And it's all free, right? There's no reason not to at least try if you're curious. Worst case scenario, you try it, you figure out you don't like it, and then you move on with your life. So Exploitation and all the things on over the wire are free. All you need for over the wire example is an SSH client. So you have to connect in with SSH. And if you're on Linux, there's an SSH binary installed by default. Probably on a Mac as well. I don't know. I'm not a Mac user. On Windows, Windows has come a long way, and they do have a native SSH client installed as well. And it's been like that for like, I don't know, maybe 4 years. So I can just type SSH and then look at the help, or just SSH. And it does print out the like help, right? So SSH is installed by default on Windows, which is super, super cool. You no longer have to install third-party tools like PuTTY. Next up, I wanted to highlight PWN College, which is an amazing, amazing resource for learning computer science in general. I kind of characterize it as a computer science platform with cybersecurity intermingled into it. So it's not pure binary exploitation, but it does cover that as well. So if you already have some type of computer science background, I think PWN College is awesome. It is taught by professors at Arizona State University, so it is university academic level material. It is free. I highly recommend it for learning any type of low-level cybersecurity topics. And then here are some of the dojos I recommend. There are several listed here. Let's do like a little walkthrough. So I have it opened up here on the page. I have a free account. I'm logged into my account. And you can see some of the challenges I've started. So if you're brand new, you can go to the Getting Started module. And it'll just show you how to use their platform. You can do everything through like this web GUI, which is super nice. You don't need to download any additional software. So if you're on the go or you have a computer with limited resources, you can learn everything through your web browser. They have a section on just Linux. They have some optional refreshers that go over, I believe, like using the debugger in GDB, and a crash course on assembly, how to run programs. But like the real crux of it, like the real academic material, comes into play here. They have 4 main modules, or I guess courses. So let's click on one of them. Let's click on the system security. Let's open this up, and it gives us a blurb on what this will cover. If we scroll down, we do see it does cover some kind of like advanced topics on binary exploitation and memory corruption. We see something called race conditions, right? That sounds interesting. Kernel security. So the kernel is that piece of software that sits with your operating system. It sits between the application layer, so like where my web browser runs, and between the hardware. It kind of sits in the middle. I use peripherals like a mouse and a microphone. It needs some way to interact with my software. The kernel, well, I guess for peripherals, it'd more so be like drivers. But the kernel is the piece of software that manages all that. It manages like the real world human connections and how that interacts with my operating system. It's a really complicated technology. And if any program, the more complex a program becomes, the more logic, the more math, the more computations, the higher chance of there being some type of programming error or flaw, because the people making these are human, and humans do error. So if you have to make some type of really complicated, really complex kernel, like think how complicated the Windows operating system is, right? There has to be some vulnerabilities there. It's just like, I don't know, by nature of writing software, there's always going to be some type of flaw, some type of bug, some vulnerability, and those could somehow be leveraged to gain remote code execution or privilege escalation. So that's really the purpose of binary exploitation. So I love PWN College. Let's open up kernel security, and we see that they have different modules or different lectures. So if I click on kernel modules, it drops down and like an actual YouTube video pops up. So this is an actual professor at Arizona State University. We can see his slides as well. And we can read and learn all about kernel modules. And then here's the cool part. We can actually solve capture the flag challenges in our web browser. So ease into kernel exploitation with the simple crack me level. So you'd click start. It would take a second to generate. And then we can either open it up in Visual Studio Code or the GUI application. So I'm going to right click and open that. And we come here, and once it connects, at the very top, you see in this menu, we do have some different options. We have a folder, not very exciting. We have a Linux terminal we can use. We have Anger, we have Ghidra, we have IDA. So these are all reverse engineering tools, very common, very popular. So we can open this up and make sure everyone can see this. So if we do an ls-tech-l, I know that's like very hard to see. All I did was list out the challenge directory, and we do see we have a kernel module here, right? If I just cd into this directory and do file star, we see that we have our kernel module, and we can play around with that. And it is a crack me, so we'd probably have to open this up in Ghidra or what have you and just find whatever flaw or exploit that they want us to take advantage of. So that's enough of PWN College right now. They don't want any walkthroughs, videos, or anything like that, so I'm not going to create any. But again, it's 100% free. It's super awesome. If you like computer security, if you like computer science, why not look at it? Next, we're moving on to some of the not free resources, the ones that you have to give up actual coin for. I tried listing these in order of like more affordable to most expensive, and just ones I personally have done myself or personally enjoy. So the first one I have listed here are Fundamentals of Software Exploitation from RET to Systems. So this is a paid online course that teaches how to exploit 64-bit Linux executables and develop exploits in Python. And it does cover some pretty modern binary exploitation mitigations, such as stack canaries, NX, and data execution prevention, ASLR. It goes into race conditions, it goes into heap, memory management. And the course is an adaptation from the modern binary exploitation course from Rensselaer Polytechnical Institute in New York. So if you cannot pay for the course, or it's just not your cup of tea, you can theoretically go to this GitHub, and a lot of the material is very similar. At least, do these links still work? Will this resolve if I click on the syllabus? Here we go. So if we see the syllabus, and I'll pull up RET2 War Games as well, and I'll pull up that course. But we can see there is an introduction to reverse engineering, so the different tools you need, memory corruption, buffer overflow attacks, shell coding. So this is very similar to the paid course. So if all you needed was like a roadmap, what order should I learn these things? This is not a bad resource, right? Because this is an actual university, is an actual institution. So you could just look through, all right, cool. What do they recommend learning? They probably link to some type of textbook, so you can get that textbook as well. But yeah, so the GitHub is there. And they do have links to the lectures. They have all the binaries, they have labs, they have slides. So if you need something affordable, this is a free resource. However, the paid one is RET2 Systems, the Fundamentals of Software Exploitation course. I have paid for it, and I have been working through this the past couple of weeks, right? So I haven't made any YouTube videos lately, and that is because I've kind of had my hands tied working through this course. We can see here all of the different chapters, all the different categories of things you will learn. So C, fundamentals, right? I thought it was important. So did the creators of this course. Reverse engineering, memory corruption, shell coding, stack cookies, ROP, ASLR, heap, and then race conditions. So I'm not 100% finished. If you do want to just test the waters and try out this course, they do have a free demo. They do have an introduction, and you can go through the C Fundamentals Challenge completely for free without paying anything. The actual course itself, I believe I paid about $300 for 3 months of access. And yeah, it is what it is. I recommend it. It is good material. Once again, everything is through the web browser. If we just open up one of these modules just to see the layout of this, let's see. So this lecture teaches about integers and how integers can be a problem in languages like C or C++. All an integer is, it's a number, right? It's a whole number, but you can overflow it or underflow it. They can be signed or unsigned. It does get a little bit tricky if you're not validating and verifying user input. So that's what this challenge is. So on the left, they have the lecture, like the actual contents of the lesson. And then in the middle, you have the source code, or right now it's the Python interpreter, but we can look through some source code that they give us, make sure that's large enough for everyone to read. And then on the right-hand side, you have a debugger. It's very similar to GDB if you've used that. So you can run the program, you can set different breakpoints. You can disassemble functions, so disassemble main. It's a debugger, and everything is in the website. So it's a cool platform. It does have some bugs a little bit just because it is in a web console and a web browser. But I really enjoy the material. I'm almost done, man. I'm almost done. I still have to complete some of these missions and then the heap, miscellaneous, and race conditions section. What else do I have to showcase? Cool. So that's the fundamentals of software exploitation course. And none of these are affiliates or sponsorships. These are actual courses I've taken myself and that I'm just recommending to you guys. So SANS, the SANS Institution, they do have something called a course called Sec 660, which is their advanced pen testing, ethical hacking, and exploit development. So the course was 5 days long. The first 2 days were about different penetration testing concepts. So not purely binary exploitation, but actual things that you would use on a red team engagement, or if you're a penetration tester or you're a consultant, you would use those tactics and techniques. And then the latter 2 days were on Windows and Linux exploitation, reverse engineering using IDA Pro, fuzzing using Ollie Debug, I think it was, and just reverse engineering. Because first you have to find the vulnerability in that piece of software, and then the second step is actually figuring out how to write some type of exploits to, for example, if there's a buffer overflow, how many bytes of data does it take to overwrite something called the return address? Now I have control of the return address. I can control the execution of the program, and I can have it execute my shell code that will either escalate my privileges or it will give me a reverse shell onto the system. So it is a very good course. One of the instructors, at least at the time I took it 2 years ago, was Steven Sims, who I do have linked below as a recommended content creator that I enjoy. He's very knowledgeable, very well spoken. He's a great instructor. And SANS courses, some of them do have an associated certification through GIAC, which is a different entity than SANS. So their certification is GXPen, so GIAC Exploit Researcher and Advanced Pen Tester. I would never recommend paying for SANS out of pocket, and they are in the thousands of dollars. And then I have our good old friend OffSec, or Offensive Security. So they have the Windows User Mode Exploit Development course. This is it focuses on 32-bit applications on Windows. So if you want to learn something for the Linux platform, they're not going to cover it here. It's all 32-bit applications, but you will be doing reverse engineering. So if that's new to you, it's great to kind of learn the concepts. And they give you a PDF as well as some videos. Right? Some of these other resources we looked at are all in the web browser, and that might not be your cup of tea. OffSec, they will give you access to their training range, like their platform, so you can actually use a debugger and you don't have to use web browser tools, because they can be a little bit clunky. I took this maybe around 3 years ago now. I did not take the exam, but I did finish the course in its entirety, and I do recommend it. I was very new to exploit development at the time, so all that knowledge for me was pretty helpful, and I did pick up some tricks from the course that I still kind of use today. So what else do I have? You reverse engineer real software. Yeah, so I didn't highlight this, but RET2 systems is great, PWN College is great, but they are kind of like capture the flag challenges, whereas in the Windows User Mode Exploit Development course, or OSED, there was actual applications. These were like legit Windows applications that you could download from ExploitDB or anywhere else online and run them on your computer. And they weren't simple CTF challenges. So it was more realistic because it was actual software that a company made or developers made to do something. Sweet. So now I have the series of FAQ. If you have any questions that weren't answered here, please let me know in the comments and I will do my best to answer them. However, these are some of the frequently asked questions that I think people have, right? So what is binary exploitation and why is it important? My definition, it's just taking advantage, leveraging some type of vulnerability in an executable for unintended purposes. We talked about buffer overflows, and I have a whole bunch of challenges on that. Integer overflows, race conditions. You have an executable, whether that's meant to be run on Linux or Windows, and it has some type of bug or flaw that you can exploit and get shellcode on. So that's basically what binary exploitation is. It's important for security professionals to recognize that, because that might be like a simple win on like an engagement, or if you're a vulnerability researcher, that's kind of like your whole job to find different flaws and bugs that you can exploit. For developers, it's important to kind of know what insecure code looks like, what the risks are for potentially programming incorrect or vulnerable code, and how people might be able to leverage that for malicious purposes. With the rise of memory-safe languages, is it still worth learning exploit development in the current year 20XX? My answer is yes. I've already made an in-depth YouTube video on this that's linked here. There are programming languages like Go and Rust that are low level, like C and C++, and they don't really have a lot of the same issues that C and C++ have. In short, C, C++, they don't do any bounds checking. So if you create an array that's like 20 bytes in size, it's not going to save you. It's not going to do any checking. If you do some user input and you call something like getString or formatted getString, and you put in the wrong size or you don't specify the size at all, it's going to keep reading. It's going to fill up that buffer and it's going to overflow. It's going to overwrite the base pointer, the return address, and potentially lead to remote code execution. Things like Rust and Go don't really have that. However, I don't think C and C++ are going anywhere anytime soon. The Windows operating system, the Linux kernel, IoT devices, smartphones, smart cameras, they're programmed with C and C++ largely, and I don't think that's really going to change, at least in the foreseeable future. Should I begin with Linux or Windows for exploit development? What are the key differences? I would recommend Linux exploitation just because there's more resources prevalent for those systems. We already kind of looked at Narnia from Over the Wire. So a lot of CTFs are based on Linux rather than Windows. So if you do want to use CTFs in war games to get started, you're just going to run into a lot of Linux, a lot of ELF files, right? A lot of ELF binaries. So I'd recommend just starting there. If you're die-hard set on learning Windows first, sure, you can. There aren't as many high-quality resources, in my opinion, for learning Windows exploit development as there are on Linux. However, either way, you need to learn assembly. Linux and Windows are both going to be utilizing x86 or x64 assembly, and the only real difference is going to be those calling conventions that we talked about earlier. Windows has certain calling conventions, Linux has different calling conventions, and those kind of change over time as well. Who typically hires exploit developers and what roles do they fulfill? So I guess this one's kind of still a work in progress, but so big tech companies, they're going to hire exploit developers, binary exploitation professionals, reverse engineers, vulnerability researchers. So here I have a few entities listed. I have Google Project Zero and I have IBM X-Forced, but there are a lot more. So exploit developers specifically, That job title, it'll probably be for the government. And here I have listed the Alphabet Club, and that just being like the 3-letter agencies of the US government. They will probably have job titles labeled as exploit developer or CNO developer. Traditional companies, private sector companies, they probably won't have exploit developer listed, but they would have vulnerability researcher, reverse engineer, things like that. And as part of a security researcher, you're trying to find flaws and bugs, and you're going to write a proof of concept exploit in something, and probably like Python. So exploit development is a big portion, but reverse engineering and just understanding computer code and programs and business logic is probably a bigger function of your day-to-day tasks. And then lastly, I have, hey, you can always just work as a freelance vulnerability researcher, do bug bounties, find an exploit. There's Zerodium. It's like a bounty of like exploits, and they pay out pretty well. How long does it take to become proficient in exploit development? So this can vary person to person. So if you already do have experience as a programmer, reverse engineer, penetration tester, if you already have some type of technical experience, of course it's going to be easier. Of course you're going to probably learn a little bit faster than someone who's just walking into this for the very first time. So any knowledge you have, it can transfer over to your current discipline of exploit development. There's no real time frame. I would recommend for the first maybe year, however long it takes you to get comfortable, just start with capture the flags in war games. Don't try to reverse engineer iOS 18 or whatever the latest version of iOS is. Don't try to start with exploiting or reverse engineering Windows 11 kernel with all security mitigations turned on. It's just going to be too much. It's going to be confusing, and it's going to be extremely hard, right? There's a reason there's huge payouts for like a Windows 11 0-day that works for remote code execution with no user involvement. So it's hard. So recommend, for example, in that scenario, instead of starting with Windows 11, maybe start with Windows 7 or XP. When some of these current modern day not vulnerabilities, these modern day exploit mitigations don't exist. So vulnerabilities don't really change. Like a buffer overflow is a buffer overflow. However, and if I come here to this RET2 systems, for example, if we look on the left-hand side, these all take advantage of like buffer overflows. However, the only thing different is what mitigation is being turned on. So, for example, stack cookies, a special value added to the end of the buffer that gets checked when the function is returned. So normally you'd overflow the buffer, overflow something called the base pointer or the frame pointer, and then you'd overwrite the return pointer. Sandwiched in between that is something called a stack cookie or stack canary. It's a randomly generated 8-byte value. In the binary, the executable, it expects that to stay the same. So if you overwrite that, when you overwrite the return address, it'll be different. And the program will error with something called like an exception. It'll say stack smashing detected, and it'll error out, and it won't let you do your shellcode injection. There's ways around that. We won't get into it. And then, so that's one mitigation you turn on. A couple years later, they introduced NX or DEP, so non-executable data execution prevention, and you can use a technique called return-oriented programming that we showcased on the channel before. What about ASLR? What about if my addresses are random and I can't just hard code a return address and now the addresses are random? So the vulnerability is the same. It's still a buffer overflow, but now they just turn on different protections that make it harder for you as an exploit developer. So it could take however long it needs to take. What tools and software are essential for learning exploit development? Some I have listed here. A debugger, a disassembler, a fuzzer, a scripting language, and a text editor. I try not to list like specific products or tools, but just like concepts. So you use any debugger you prefer, whether that's GDB, Immunity Debugger, Ollie Debug. Same for a disassembler. AFL is like the common standardized fuzzer. Scripting language, I prefer Python. However, I have seen some write-ups on ExploitDB using Perl. So whatever floats your boat. And then a text editor. I like Visual Studio Code and Vim, but use any text editor or IDE that you prefer. This article is longer than I thought, man. Are certifications important for exploit development jobs? If so, which ones? So for people entering cybersecurity for the first time, maybe from a different background or fresh out of college, certifications can be a great way to show that you know a baseline level of knowledge. Security Plus, OSCP, whatever. So for traditional things like pen testing, security analyst, to get your foot in the door, yeah, do certifications. However, exploit development, reverse engineering, security research, you don't really need a certification. They can be very helpful, especially if you like structured knowledge. However, just reading job descriptions of like on LinkedIn and different job boards for security researchers, vulnerability researchers, they want to see participation in capture the flag challenges. They want to see publications you created, articles you wrote, previous previous bugs and vulnerabilities that you have found and that you've disclosed, CVEs that you have assigned. But yeah, always check the job description for the role that you want to apply for and see if they suggest any certifications. For a lot of low-level binary exploitation, reverse engineering jobs, you're not really going to see certifications, but they will expect you to be proficient in C, C++, and proficient in your tools. So when we talked about debuggers and disassemblers, your tools would be IDA Pro, Ghidra, Binary Ninja. So displaying competence in one of those tools, plus a programming language, plus understanding all the different security mitigations for Linux and Windows, that will be more beneficial than taking an exam for certification. The last Q&A I have here, what common mistakes should beginners avoid when learning binary exploitation? Patience is key. This is a hard industry. This is a hard field. Cybersecurity in general can take a while to kind of wrap your head around. So for something as low level as learning assembly, finding flaws and bugs that you can exploit and get past all those mitigations that are turned on, it is difficult. And I think it'll continue to get more and more difficult. So that's why you need to be patient. However, as it gets more difficult and like the demand for kind of this thing rises, the payout should be better. The juice should be worth the squeeze, right? So this can be a very challenging field. It can take a long time to truly grasp some of these low-level concepts. However, patience, persistence is key. And you can't always do it on your own. So here I list some content creators that I personally enjoy. I recommend. They're very knowledgeable. They've been in this field a long time. So first and foremost, I have Live Overflow. He has a whole YouTube playlist on binary exploitation for beginners. He walks through exploit education. John Hammond, right, the legend. He has a bunch of videos on reverse engineering, binary exploitation, penetration testing. Steven Sims, he is the curriculum lead for the offensive security track at SANS. Hopefully I got that correct. And he recently, a couple years ago, started his own YouTube channel. He does a whole bunch of live streams. So the channel is called Off by One Security. Recommend checking that out. And then the exploit.club newsletter. This is a weekly newsletter that releases every Thursday, and it has links to different write-ups for CTFs, real-world vulnerabilities and exploits, as well as at the very bottom, they'll list relevant job descriptions as well. So there you have it. This video went on a little bit longer than I meant, but hopefully it was helpful. Hopefully, if you are someone who wants to get started with binary exploitation, maybe some of these resources really stuck out to you. Let me know what questions and comments you have down below. And the final thing I do have on the agenda, we do have a little bit of a merchandise update. So over the weekend, we created some of these nice coffee mugs. So we created 3 total. Let's kind of just peek at them real quick. So we have this exploit developer one. It says, exploit developer, my other computer is your computer. And then we have some shellcode listed here. And click through some of these icons. You can read the description for yourself. Hopefully these are reasonably priced. I don't want them to be too expensive, but I really am happy with how the designs came out. This next one we have is great for Valentine's Day or great for any lover you have of computer science or computer security. It says, our connection is more secure than HTTPS, and it has a nice little design on the front and the back. Hopefully you guys like that. And they're all the same price. They're all $15. And then lastly, we have the Script Kiddie mug. So this is pretty much me, right? Eternal Script Kiddie. Always going to be a beginner. So this one you can get in different colors. It does have the black or the blue, the orange, or the hacker red. I like the hacker red. And on the back, I do have a little like word bubble of like different hacking terms. So hopefully you guys like that. I am wearing one of our shirts, the Lo-Fi New York Hacker shirt. And we do have one for the city of Chicago as well as some other merchandise. The feedback I've gotten has been pretty well received, thankfully. People say the material, the quality is really good. And yeah, that's really it. Hopefully you guys enjoyed the video. Let me know in the comments down below what questions you have, what I can answer. Binary Exploitation, it's a marathon, not a sprint. It can take a long time to get kind of proficient or even understand what the heck you're supposed to do in the first place. As always, guys, take it easy and see you in the next video.